Good afternoon. My name is Ravi Babu, Assistant Professor in IARE Department. Today, in Digital Control System, in Module 1, that is Sampling and Reconstruction. In that one, today we are going to taking the zero order port device. Okay. In case of the hold operation, the zero order hold device is a part of the construction process, where here data hold operation is a processing getting the continuous time signal y of t from discrete time signal. That is where, see, in case of the data hold operation, we are going to generating the continuous time signal from discrete time signal. Okay, that is nothing but where it is only coming a zero order hold device. Generally, we are having the here. See the block diagram of that one. Here, computer, DAC, process, output, feedback or measuring system, ADC, given to here, input, this one. So generally here, these are the controller blocks, where for process we are getting, for process the input is analog signal. Okay, for example, if you take sine wave analog signal. Okay, so we get the output. From the feedback also it will be coming to analog signal. For this analog signal, we are going to convert it into digital signal. Why? Because for computer, input is digital, output is also will be digital. That's why here we are going to be converted into digital signal. Okay, in already previous class we will explain the ADC function, where as ADC is containing the sampler, and quantizer and encoder. Okay, sampling the analog signal and quantizer that one and encoding that one. Encoding to 0 to 1 and convert this 0 to 1 to the input of this one. So coming for here, in case of the between the sampler quantizer, okay, that is here we are having the block as sample and hold signal, sample and hold block. So here when in sample to quantizer part, that is nothing but if you take your sinusoidal signal, that one is converted into samples, that is nothing but like this, positive peak, like this, for positive half cycle is sample signal. This one we are going to quantizer. Quantizer nothing but we have to maintain the voltage levels. When we are going to maintain the voltage levels, here going to be process of data is going to be hold in process and it will be going to be reconstruction process, discrete time process. Okay, for example, if you take 3, if this is 4, this is 5 volts higher value. So what happened? 3 up to 3 it is higher value. How does it happen? Up to 4, like this. It will come into like this. This is 0. Here whole operation is coming. That's why when it is coming, the generating here, the generating continuous time signal. When it is generating here, continuous time is here generating now. This continuous time signal. Okay, it is y of t. This continuous time signal from here to here, discrete time signal x of k of t in this block, x of k of t. Okay, So at the state process, the hold operation is going to process here. Okay, hold operation is going to be processing here. Okay, hold operation is going to processing here. Okay, that is the second point. Data hold operation is process of generating the continuous time signal from to discrete time signal. Okay, so what is the continuous time signal is y of t, where it is coming at output section. Okay, so that is nothing but the y of t is going to be having the internals, that is kt and between the time intervals of k plus 1 and t. Okay, approximated like this. That is nothing but it is kt. So where it is here. If you take it a time periods 0, t, 2t, 3t within this axis. Okay, sinusoidal waveform is there. It is for period t. After that one, t plus 1. After that one, that is nothing but what happened? K plus 1, k, the hold operation length, k plus 1, okay, k plus 2, k plus 3. In this process, they are going to be taking. That is the input sinusoidal signal. If I am taking type of signal, sinusoidal signal, that is sampling signal. Sorry, that is continuous signal. That is continuous signal is coming to the hold operations. That is in the form of discrete time. In the form of discrete time. That's why it is in the between. The time interval is going to be in the between k and k plus 1. K and k plus 1. So after that one here, so in the hold operations, the total final equation for discrete time systems, the total final equation is, that is y of k plus t plus tau equal to a into t power of n, a into t power of n minus 1 and up to so on a into t. This is the nth order of the whole device. Nth order of the whole device. That is the output of the continuous signal is going to be converted into discontinuous signal by the whole device after sampling process. Sorry, in the sampling process, the continuous time signal is going to converted into discrete time systems. The sampling process is continuously going, and the process also, the whole device is going to be operated with the y of t is converted into discrete time signal. Okay, discrete time signal. So this is the equation for nth order whole device equation. Remember this one. Okay, you have to remember this one. This is the equation for nth order whole devices. Nth order whole device. So now I am going to for this equation is the nth order first equation. No? So I am going for only first order device. That is nothing but, first of all, here you have to remember what is the order. Order nothing but power of the equation. Okay, nth equations. So if you take this one here, in this equation, the first order is coming for up to here. These two quantities. The first order is coming. In this equation, this is the first order device. Okay, up to first order, A1 with tau. Okay, where is this tau power is 1. Tau power is 0. Okay, 1. So next one is coming for the G order word. G order word, that is nothing but it is coming to as only this part. So it is the, in nth order device, we see the first order device equation and G order word device equation. Okay, G order word device equation. Now I am taking for, we know this is the, y of k plus tau is nothing but it is the output of the discrete time system. Where x of k plus k of t is nothing but input of the discrete time system. Okay, input of the discrete time system. That is nothing but then G order we get, that is G order word nothing but it is A naught. Okay, it is A naught equal to x of kt. X of KT. Okay, this is for zero order port device. Zero order port device. Sorry, wait for here. It is mistake, some mistake. It is coming to as A not only. Not O. Okay, it is coming as A not. Okay, so this is equal to this one. Okay, this is equal to this one. Okay, this is your nth order discrete time output nth order equation, and the nth order we are taking the first order and J order polar equations. J order polar equations. So that is nothing but y of k plus tau, this one. Coming for what is the mean by J order? What is mean by J order? That is nothing but it is a device. Okay, it is a device which holds the discrete time signal k of t till next sample comes, and this one converted into discrete time signal. Okay, it is a device which holds the discrete time signal. Hold, okay, where it is coming also. This will hold the discrete time device, discrete time till next sample comes, and this converted into discrete time signal in continuous time signals. For example, if you see this one, okay, it is discrete time signal, input signal, okay, with time periods of 0, t, 2t and 3t. Okay, input of J order word. This is the input of J order word. Where convert of this one as output of J order word is in case of output. So it is coming to as C. At the time of 0 to t, it is 0. At the time of t, our output will be maximum. Okay, output will be maximum. See, I am writing here once again. Okay, 0, t, 2t, 3t, like this. Okay, from 0 to t, it is 0. No way. Here, output is not existing there. Okay, from at the t, it is going to increase some voltage level, 3 or 4 or 5. Just now I explained, no? 3 or 4 or 5. So that's why it is coming to us at here some amplitude. Okay, this is coming to us for some amplitude. After that one, that is t to 2t, between t to 2t, it is also off position. So nothing but it is 0 order word. Up to here, up to 2t. Like this. Up to 2t. Okay. And what is the 2t value magnitude? 2t value magnitude is some value. If you take it is 3, if you take it is 3, it is 3, it is 4, it is 5, 3, 4, 5. So what happened this one? After 3, it is value, no? So after that one, it is whole operation. Okay. So what happened with this magnitude? It is increased. At 2t, here, at 2t, what is the magnitude? 4. Similarly for here also, 4. Okay, 4. So after 2t, again, whole operation is coming. Like this. Up to where? 3t. After 3t, at the time of tt, it is going to be this. That is 5 volts. Like this. Again, it is falling to fall. Like this. Okay. So, if you add in this one, analog signal is coming. Okay. This is the J order port device. Okay. Now, coming for, if you take, this is for J order port device now, I am going for the input is impulse function. For impulse function, R equal to 1. That is, the unit length of the impulse function is 1. Where up to 0 to t. Up to 0 to t, it is 1. Okay. After that 1, it is going to be 0 position. That is nothing but after this one, these values, it is not going to be exceeded. Okay. It is not going to be exceeded. So, for impulse function, it is and coming for this one, the transfer function of the G order word. Okay, so we are going for unit step function. Convert this impulse function into unit step function, that is G of h of t equal to u of t minus u of t minus t. Okay, this is nothing but G order transfer function. G order transfer function. Okay. G order transfer function. Okay, so this is u of t equal to, here it is a unit step signal, this part u of t equal to unit step signal, and it will come to move to up to the end signal. Okay, so it is moved to come to the end signal. Okay, end signal, where u of t minus t here. So that is come to like this. So it is going to be end of the signal. It is end of the signal. That is nothing after this one. After this one. So here g of h naught equal to the transfer function. Coming for the transfer function of the G order pole. G order pole. Coming for the transfer function of the 0 order pole. So this is your standard function. You have to remember, that is G of transfer function is, okay, 1 minus e power of minus st by s. This is a transfer function of the G order. Now we are going to be derive this transfer function in three approach methods. What is the approach methods? We will see. Okay, what is the main approach methods? We will see. Okay, so coming for here, you have to remember that is G of h of s equal to 1 minus e power of st by s. st by s. Coming for here, first approach method. What is that one? This is a transfer function 1 minus e power of st. You have to take the proof of this one. Okay, in case of the first approach method, I am taking the g of s is applied for the Laplace transform. So we are going to be applying the Laplace transform of g of h. Okay, g of s. So what is the formula for g of s? Generally, what is the g of s equation? Where is it? This is g of t. Okay, so g of h of t equal not equal to, that is this part, u of t. So this equal to g of h of t equal to, what is one? U of t minus t minus k. U of t minus k. Substitute this one to here. This place. Substitute. So what happened? Laplace transform of u of t minus t. So what is the Laplace transform of u of t? Okay, 1 by s. 1 by s. Now what is the Laplace transform of u of t minus 1? That is nothing but before the time period of existing signal. That is equal to e power of minus st by s. E power of minus st by s. Okay, so this is what matching now. This is matching now. Okay, 1 minus e power of minus st by s. Okay, so this is your first approach for zero-order pole devices. Next, second approach. Coming for the second approach, first of all, we have to analyze this black diagram, small diagram, where it is a transfer function. Now you have to prove this one. See this one. I have proved. How it is possible, you can see. Second approach, where x of t is the continuous signal. It is continuous signal. T is the sampling period, signal. Okay, sampling signal. This is your discrete time signal. Discrete time signal. Okay, discrete time signal. Now, this discrete time signal is going to be applied in ZOH. This is nothing but ZO, zero order word transfer function. then OHTF. I want to take zero about transformation. So for that one, we can write the equation as here. This method is commutative methods. Commutative methods. Okay. So see this one. Duration part. The expression for the y of t can be written as y of t equal to sigma k equal to 0 to infinity x power kt plus into g zeta t minus t naught. Okay, this is our cumulative function. Cumulative function. What is the cumulative function? That is nothing but you have to derive the equation from analog to digital. No, from where voltage device is going to be written, that is analog to digital. That's why we have to take in their cumulative equation. Okay, cumulative equation. That is y of t equal to 0 to infinity. Okay, x of kt. Okay, g of kt. We have to apply here. So what happened? This x of kt next is taking common. That is whatever the g of t minus t kt. G of t minus t equal to you can use here u of t minus kt minus u of t minus kt minus 1. Okay, see, I am taking here x of kt is common. So u of t plus kt minus u of t minus kt. So taking the Laplace transform in both sides. Taking the Laplace transform in both sides. What happened? It is y of t is converted into y of s. X of kt is same. Taking the common, x of kt minus tt equal to e power of minus s kt by 2 minus. So e power of this part is e power of minus k plus 1 into tau. Okay. After this one, I am taking the x of kt e power of minus kts part is taking outside. So what happened? 1 by s. This one I am taking outside. So it is coming to as 1 by s and minus e square by s. Where here the 1 minus e power of s is common. Okay, 1 minus e power of s is common. So what happened? If you take it is common, only limits is applicable for this part only. Only applicable for this part only. Okay. So what happens is this part is coming to as x of star conjugate of x of star. Conjugate of x of star. That is the point we get the discrete time signal. Okay. This is your second approach. Coming for the third approach. Okay. In case of third approach, first of all, we are writing the discrete time signal. So it is your discrete time signal for unit step. So x of kt 0 1 0 0 1 up to 1. Next, the step response is that one is stable. Unity. This is your step response for the stable or unity. Okay. Now coming for here. For the third approach, y of s equal to Laplace transform u of s. Okay. That is u of s. Okay. So I am taking the conjugate. And taking the conjugate of this one. Okay, that is conjugate of s equal to this part. Conjugate of s to e power of st by st. That is nothing but st by s. Okay. Now we are going for where this conjugate values are going to be equal to 1 by a. Similarly for z equal to also same as 191. Okay. Next. So it is coming to us for simplification of this term, we are getting the this version. Final answers. As you know, final answer. We are going to be taking the final answer of this one. Okay. So finally, what I am saying is, I am going to here concluding that one is finally for finding of transfer function of first order whole device, third approach is method. Okay. For whole devices and first order system. Okay. Third approach will be finding method. Okay. Next. Because the first order and data order, we can get the expressions for impulse response by taking it as a GYH. Okay. So what I am saying is, the first and second method is going for G order word. Third method is only for first order word. Why? Because the first order word is nothing but cannot get the expressions for the impulse response for directly. Directly impulse response is not coming from first order system. That is nothing but G order word devices. G order word devices. Okay. Now this is a total conclusion of the zero order word devices and G order word devices. Now this is your continuation of G order word device. Today is completed. Now tomorrow I am going to for this session we are going to divide, taking the as it is first order word devices. First order word devices. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.